Welcome to part 21 of our series on building a Zelda-like game in Phaser 3. In this video, we'll complete our object interaction mechanics by implementing lifting and throwing. If you're new here, this is part of a full series where we create a Zelda-inspired game from scratch. Check out the playlist link in the description to start from the beginning. Alright, let's dive in and start smashing some pots. Now that we have our logic for hiding our game object in place, let's switch back over to our throwable object component, and we're going to focus on adding in our logic for throwing our game object across our level. So in our throw method, first we'll want to validate that our game object is actually an arcade physics body so we can update its velocity. Let's get rid of our to-do, and let's start off with if not arcade physics body. We'll do that game object, the body, and if it's not, we're just going to call our callback right away. So we're just going to wrap this inside our if statement here. And then we'll do return. If it does have an arcade physics body, we want to reset its velocity. And so we'll do const, we'll do our body, will be equal to this, our game object, our body. Now we can do our body velocity, our x, we'll set it equal to 0. We'll do the same thing for y. And now depending on the direction that we threw our game object, we'll want to update the appropriate velocity. So we'll add in our switch. Let's do our direction. Let's start with our direction down. So we'll do our body, we'll do our velocity, let's do our y velocity, and we'll set it equal to a new variable. We're just going to call this throw speed. Now we'll want to do break, and let's define that new variable. And so we're going to do const, we'll do our throw speed. And for that, we'll make a new config item, and we're going to call that throw item speed. So if we jump over to our config file, let's add that new property now. So at the bottom of our file, we'll do export, we'll do const. We'll do our throw item speed, and we'll do 300. And so while we're here, let's add in one more property. So let's copy this line, let's paste it. We're going to call this throw item delay before callback. So we'll do throw item delay before callback. And for that value, we're going to do 200. And how that will be used is after we throw our game object, we want to wait a small period of time before we have that object land in our game, and then it would break. So if we come back to our throwable object component, let's update our import. We'll fix our reference. And now we want to do our other direction. So let's just copy this code. We're going to paste it 3 times. So now we'll do up, left, and right. So now when we throw up, we just want to multiply this by -1, so it goes in the other direction. When we go left, we also want to do -1, but we want to update this to be our x value. And we'll do the same thing down here. Let's add in our default block. So we'll do default, our exhaustive guard, and we'll do direction. So now after we throw our game object, we'll want to re-enable our arcade physics body, so then that we will be able to check for collisions between that object and other objects in our scene. And so to make that change, we'll do this, we'll do game object, and now we're going to call our new method. So we'll have enable object. So now to use our new method, let's come up to the top of our throw method. When we do our safeguard check here, after we do our check for physics body, we're going to make sure it's one of our custom game objects. And so or not is a custom game object, and we'll pass in this game object. So now we validated it has the properties we need to call enable object. Lastly, after we re-enable our physics body, now we want to do that delay before we reset our velocity. So let's do this, we'll do our game object, let's do our scene, now we'll do time, and we want to do a delayed call. For our value, we'll do our throw item delay before callback. And now in our callback, we'll reset the game object's velocity. So let's copy these. And then this is where we'll also call our callback. So we'll copy that, paste that down here. Now let's save. So we come back to our browser, let's pick up our game object. So after we pick it up, if we throw it, we'll see now it animates across our screen and it will break after that delayed call that we added here. So now if we try throwing our game object in the various directions, we should see our game object throws in that direction. Nice. So it just looks like we have one issue, and it's tied to our game object. We want to throw it in the direction down. So we pick up our object. If we throw it down, what's happening is our physics body is getting re-enabled when it's above our player, and it's pushing our player down. To fix that, we're going to shift our game object to be in front of our player before we throw it. And to do that, we'll do this. We'll do our game object. Let's do our Y, and we're just going to add 20 to it so it's in front of our player. So now if we pick up our game object, let's try throwing down. Much better. Now that we re-enabled our physics body for our game object when we throw it, we want to work on adding our collisions for when that game object collides with one of our enemies so we can have it break. To make it easier to test, let's go into our 2 enemy classes and we're going to disable their state machine so that way they won't move around our scene. So we'll go into our spider class. Let's just comment out where we set our state for our idle state. Next, we'll go into our Wisp class, and we'll comment out our logic for where we start animating our game object around our scene. We'll come into our Wisp class, and let's disable our set state here. Now if we come back to our scene, and so now if we pick up our game object, let's throw out our spider enemy. We'll see as soon as our game object collides with our enemy, we detect the collision, but now we're pushing our enemy back. Instead, after our object hits our enemy, we want to break our object immediately and disable our collisions, and then have our enemy take damage. Likewise, if we pick up our game object and we throw it at our Wisp, we don't want it to actually affect our Wisp, and we want to have the object just pass through it, since we can't actually do any damage to our Wisp game objects. To add these changes, let's jump over to our game scene. We'll come down to where we register our collisions. So now in our collider, for our collisions between our blocking group and our enemy group, this is where we'll add that logic. So we'll start off with our collision callback. We're going to check our type of game object, and if it's an instance of our pot, then we're going to see if our game object's velocity is not 0, and if it's not, we know we threw that game object, and so now we'll want to trigger our logic, we'll have it break, and have the enemy take damage. So let's do if. We're going to reference the game object that was provided, and we'll do instance of our pot class, and if it's an arcade physics body, so we'll do our game object body, and now we'll do and, so either our x or our y velocity is not 0, so we'll do our game object, our body, our velocity, our x does not equal 0, or game object, our body, our velocity, y does not equal 0. Then we want our enemy to take damage, so we'll do const, let's do our enemy game object, we'll set equal to our enemy as a character game object, and I'll do if our enemy game object is an instance of our character game object, then we'll have our enemy game object, we'll call our hit method, and now we're going to pass in our player's direction, and we'll just say 1 for our damage. Now for our game object, we want to call our break method so we can break our pot. So now if we come back to our browser, let's pick up our game object. If we throw it at our spider, we'll see now we have our collision right away, our enemy takes damage, and because of our state machine, it now transitions to its next state. So now for the issue with our Wisp, in our collider, an additional argument we can provide is another callback for if we should actually process a collision between two game objects. How this can be used is this allows us to return true or false if we actually want to have the two objects collide. So in this callback, let's pass in our two arguments. We'll have our enemy and we'll have our game object. And now in this callback, we want to check to see if our enemy is an instance of our Wisp. And if it is, we want to return false. Otherwise, we'll default to true. So let's add in our default. So we'll return true. So now we'll want to check the type on our enemy. So we'll do if our enemy is an instance of our Wisp class, and if our body on our game object is an arcade physics body, so we'll do our game object, and now we'll do our body, and we'll say and now our body velocity does not equal 0, then we want to disable our collisions. So let's just copy this part here, we'll paste that in, and so if that's all true, we're going to return false. So now for our game object that we're receiving as an argument, we'll see that our type can either be an arcade physics body, a tile, or it can be an arcade game object with a body. So now to fix our IntelliSense, we just need to type our body that's being returned on our game object to have the appropriate type. So outside our if statement, let's just do const, we'll do body, we're going to set it equal to, we'll do our game object, and we're going to do as unknown, and we'll do as game object, and now we'll grab our body property from our game object. Now what we can do in our checks here is we'll just reference body instead of game object body. Alright, so now if we save, let's come back to our browser, let's pick up our game object, and now when we throw it at our Wisp, we'll see our game object passes right through it. Nice. One last change we'll want to do for our collisions is we'll want to add in logic to handle when our game object collides with our other blocking game objects. So when we have our pot, if it collides with one of our chests, we want our pot to actually break. And to do that check, we'll need to add a new property to our class to keep track of all of our pot game objects that we create. So on our class, let's make a new private property and we'll do pot game objects. And we're going to set this to be our pot class and we'll have an array of those. Now down in our create method, let's copy our logic where we create our pot. We're going to move that outside our blocking group. Paste that here. Let's store that in a new variable. Do const pot will be equal to a new pot. Let's initialize our pot game objects array. And now after we create our pot instance, we'll do our pot game objects, and we'll do push. We'll add in our new instance. And now in our blocking group, we'll replace that code with pot. So now down our register colliders method, first we're going to check to see if our pot game objects, if our list is greater than 0. So we'll do if this, our pot game objects, our length is greater than 0. Now we want to add in our new collider. So we'll do this, our physics, we'll do add, collider, we'll pass in our pot game objects. And now we want to do this, our blocking group. And for our game object, we'll do pot. And now we're just going to do a check to make sure our pot is an instance of our pot. And so if not pot instance of our pot class, we can return. If it is an instance of our pot class, we'll do pot.break. So now back in our browser, let's pick up our game object. We try to throw it at one of our chests. We should now see our game object now collides with our chest game object. Our last piece of logic that we need to implement for throwing our game objects is when our player picks up one of our game objects, we need to animate that object to appear that our player is picking it up. Now, depending on our direction that our player picks up our game object from, we'll want this animation to be a little bit different, so that way it looks like the player is lifting it up from that position. To create this animation, we need to create a path that our game object is going to follow, and then that way it appears that it's following our player's hands until our player's hands are above their head. To create this path, we're going to use the phaser cubic Bezier curve. And so how this works is we need to define a line for a path our game object will have it follow. This line will have a start and ending point, so it's going to be a straight line. To get our curve, we have to provide 2 points where we want to pull on our line and kind of pull it up. So we have this control point here, this control point here, and that's what controls this curve for our line that gets created. Once we create this curve, we can then have our game object follow that curved path, and we can animate it along that path. And so to add this logic to our code, let's go over to our lift state. So now in our state class, after we update our object's origin, let's start off by creating our 4 points for our line. And so we'll do const, let's do our start point. We're going to set that equal to a new phaser. We'll do math. We'll do a vector2. And now we want to provide our X and Y position of where our line is going to start. For that, we want to do our game object that was picked up. We want to grab our X value, and we're going to increment it by 8. And now we want to do our game object being picked up. We want to do our Y value, and we want to subtract 8 from it. Now let's copy this line of code. We're going to paste it 3 times. And now let's do our endpoint. And so for our endpoint, we're going to want this to be above our player's head. And so we're going to reference this, our game object, our X value. We'll get rid of our 8 here. And now we want to do this, our game object. And now for our Y value, we want to subtract 8, so it's above our player's head. Now for our 2 other points, we'll do control point 1. Copy our variable name, we'll do control point 2. And so now for our control points, we'll keep our X value, but then for our Y value, we're going to subtract 24. And so we'll do the same thing for both these points. And now after we have our points, we can create our curve game object. And so let's do const, we'll do our curve. We're going to set that equal to a new phaser curves. We'll do a cubic Bezier. And now we want to provide our 4 points. We'll have our start point, control point 1, control point 2, and now our endpoint. So now that we have our curve, we need to create a path for our game object to actually follow. Let's do const. We're going to do our curve path. Now we'll do a new. We'll do our phaser. We'll do our curves path. And so now for our path, we need to provide our X and Y value for where our path is going to start at. And we want this to match our start point. So let's do our start point.x. We'll do our start point.y. And so now that we have our new path game object, we need to call our add method to add our existing curve. And then that's going to give us the curve for our game object to follow. So now in order to be able to see our path, so it'll be easier to debug, we're going to create a graphics game object, and we're going to draw out our path. So let's do const, we'll do G, we'll do this, our game object. Let's grab our scene. We're going to do add, we'll create a graphics game object. Now we'll do g.clear, g.lineStyle, so we can see our line. For this, let's do 4, and we'll do 0x, 00, ff, 00, 1. Now if we want to draw out our path, we can reference our curve path. We can call our draw method, and now this expects the graphics game object that we want to draw to. So we'll pass in g. All right, so before we test, we just want to add in our phaser import. So I'm going to copy that from one of our classes. We'll come to the top of our file. Now we'll save. So now if we test, let's come over to our scene. Let's have our player pick up our game object. And we'll see now, depending on our player's position, we have this new green path show up, and that's the path our game object is going to follow until it gets into the ending position. So now if we do a few other tests, if we pick up our game object from the top, we'll see based on our player's position, we'll have a new path that gets drawn, and that's the path we want our game object to follow. Same thing from our other side, and then just depending on where our player's at, next to our game object, that path will be different each time. So after we have our path game object, we just need to update our game object that's being thrown to follow that path. To do that, let's make a new variable, do const. We're going to call this follower. We're going to set it equal to this, our game object's instance. We'll do our scene. Now let's do add, and we want to do a follower. So now for our follower, we need to pass in our curved path. So our path we want to follow. And now our X and Y position of where it should start at. For this, we want to match our start point. And so we'll do our start point dot X and our start point dot Y. And so now for having our game object animate along our path, we don't actually pass in an instance of our game object. Instead, we pass in its texture, and then that same texture will be animated along that path. So we'll do our game object being picked up, and we want to grab our texture from that object. And now we're going to call set alpha. And then that way it's going to be visible to our scene. So now after we have our follower, we want to call the start follow method to create our animation. So we're going to do our follower, we'll do our start follow. Now for our tween, we'll do our delay of 0, we'll do our duration to 250. Now on complete, we want to clean up our game object, so we're going to do follower, we'll do destroy. We're going to destroy our graphics game object. And then finally, we want to update our game object that's being picked up to have its position be our end position. And so we'll have our game object being picked up. We'll call set position. And we'll do our follower.x, our follower.y, and we'll call set alpha. And we're going to set it to be 1. So now if we come back over to our scene, let's try picking up our game object. And what we should see is our game object is going to be displaced. We have our new texture being rendered for our path. And all we need to do to complete this is we just need to hide our game object while we're doing this animation. So after we create our graphics game object, we'll do our game object being picked up. We're going to set our alpha property, and we're going to set it to be 0. So now if we want to test, let's go and pick up our game object. And now we have this very fluid animation of where our player picks up our game object. Nice. The last thing we'll do in our lift state class is we're going to move some of our properties here to be part of our configuration. So we jump over to our config file. Let's do export const. We'll do lift item animation delay. And we'll set that equal to be 0. And now let's copy that. And we'll do lift animation, and we'll do duration. For that, we'll set it to 250. And we'll paste it one more time. We'll say lift animation, and we'll do enable debugging. Let's set that to be true. Now if we jump back over to our lift state, let's grab our properties, and so we'll do for our delay, let's do our lift animation, our delay, and our lift animation, duration. Now, before we create our graphics game object, let's do a check, we'll do if our lift item animation enable debugging. If that's set to true, now we want to create our graphics game object. And so to make it so we can destroy our graphics game object, we'll just do let g, we're going to add in our type, we'll do a phaser, a game objects, a graphics, or undefined. We'll assign g here, and so now we'll just do if g does not equal undefined, then we'll call our destroy method. So now if we come back over to our scene, we should still be able to pick up our game object, and we should see our debug line. Go into our configuration, let's set that to be false. Now if we pick up our game object, it'll follow our path, but we just don't see it in our game. With most of our logic in place for carrying items, we have one more case we need to handle. So when our player is carrying an item, if they take any damage or they die, our game object will stop following our player, but that game object is still associated with our components. So we need to update our hurt and our death state, so if they're carrying an item, we'll drop it, and then that way we can have our pot break when it hits the ground, and then it'll also clear it out from our components. To make that change, let's open up our throw state. Let's copy our logic here for our held component and our throw object component. So let's copy this block of code. We'll come back to our hurt state. After we reset our body's velocity, this is what we'll add in that check. So let's paste in our code. Let's update our imports. Now we just need to make a few changes. When we reference our throw object component, instead of calling throw, we want to drop our game object to remove it. So let's get rid of this argument here. And then up here, instead of returning early, we just want to have a safeguard to make sure we have a held component and we actually have an object. And so we're just going to do the inverse of this. We'll make sure our held component is not undefined, and we'll make sure our object's not undefined. And as long as that's the case, then we'll run this code here. So let's move this inside our if block. And then we want to change this to be and. All right, so with that change, let's copy this block of code here. Let's go into our def state. Let's paste it after we reset our body's velocity. We'll update our imports. Now to test our changes, let's pick up our pot. And when our player runs into our enemy, we now take damage, and then our pot will break. To test our def state, let's go into our config file. We're going to update our player's starting health. And we're just going to update this to be 1, so our player should die as soon as they take damage. So now we pick up our object, go into our def state, our object drops, and it breaks. Nice. With that last change, we now have our core logic in place. We're able to pick up and throw items in our game. Before we move on to our level design and creation section, I want to take a moment to refactor some of our code in our states. So in many of our states, we're adding this block of code where we're making sure we have an arcade physics body, and if we do, we reset that body's velocity, x and y values. Since we're placing this in many of our states, it makes sense for us to add a new method to our base character state class that'll do this logic here. So if we open up our base character state class, let's add a new method, and we'll do a protected method, and we'll do reset object velocity. For this method, we won't return anything. And since it's protected, let's add in our underscore. All right, so now for our method, let's open up our test state. Let's copy our block of code where we reset our velocity. Let's go into our base state. Let's paste that in. We'll update our import. And now if we go back to our test state, we can remove this block of code here, and we can just call our new methods. We'll do this, and we'll do reset object velocity. And now we can make that same change in our other components. So let's copy this line of code. Let's open up our herd state. So let's paste in our line of code where we reset our body's velocity. Now down here in our check where we grab our object's body, we'll just remove our velocity check here. While we're here, let's grab our code for our held component, and we'll do that outside our arcade physics body check. And then down a little bit further, we have one more spot where we reset our velocity, so let's replace that code. Now if we save, let's go into our idle holding state. We'll replace our code there where we do a reset our body velocity. Let's jump over to our idle state. We'll update our code there. Next, our lift state. Replace our logic there. All right, so next we can skip the move holding state and our move state. Let's go into our open chest state. We'll update our logic there for reset our velocity. Then finally in our throw state, we'll do our last change. And now if we save, we should be able to test our game, make sure everything's still working. So we should be able to move our character around. If we take damage from our enemy, we should transition to our herd state. If we pick up our item, we should be able to throw it. Now we try opening up our chest. Nice. Finally, one last change we're going to do to our code base is when we add in our function for isCustomGameObject, we place this function inside our types file. All of our utility functions actually belong in our utils.ts file, and so we're going to move that function over there. So let's copy our code. We'll remove it from our types.ts. We'll paste that in here. Now let's update our imports so we have the appropriate types. Now that we moved our function, we need to update our throwable object component. So if we go into our throwable object component, let's remove that from our import. Now we'll re-import our function so it comes from our utils file. That's it for this part of the series. If you found this helpful, be sure to hit the like button. It really helps out the channel. And if you're following along, make sure to subscribe and turn on notifications so you don't miss the next video. If you have any questions or want to share your progress, drop a comment below. I'd love to hear from you. Alright, thanks for watching and I'll see you in the next one.